It's nice to come in 15 minutes after class. So we've got a do-jigger here, and it is -6 and +8. So I'm going to go over here while y'all are working, -6 and +8. That's not going to work. I just pull it up. Supposed to be able to make it bigger, but I guess that's as big as you get. Turn this on, turn this on. Yeah, just come on in whenever, that's fine. So -6, that's 3 and 6. And +9, or whatever it said. That's not 9, it's 8 maybe. Okay. So -6, +8. -6. So -6 squared plus 8 squared is equal to c squared. 36 plus 64 is equal to c squared. C squared is equal to 100. The square root of 100 is 10. So our hypotenuse is 10. So the sine is equal to opposite 8 over 10. That means the cosecant is equal to 10 over 8. And cosine is equal to -6 over 10. Secant is equal to -10 over 6. Tangent is equal to of apple, so that would be 8 over -6. And cotangent is equal to -6 over 8. And of course, at this point, you finish it and reduce, and I'm not worried about reducing. And I'm just going to focus on these two, this guy right here. 8 over 10 is equal to 4 over 5. So, how do you find the angle? Well, just write like this. Sine of theta is equal to 4 over 5. Solve for theta. Divide by the sine. Divide by the sine. Theta is equal to, bring the sine up, that becomes the sine for the -1 of 4 over 5. And of course, look on your calculator, and you'll see it in your sine. Go ahead and pull it up. And we go to our handy dandy calculator. I'm going to pull this down for a second. There's our calculator. And I'm going to type second sine 4 divided by 5, close parentheses. And that's just probably radians. because I'm not, it must not be in degree mode, so nope. Go to handy dandy degree and get out of this, second quit, second entry, and that, do you mind? I'm trying to teach. That's 3. I should throw you out. 53.13. Now, of course, you can change that, and you can actually, I think you can hit math, and I think somewhere in here is degree, minutes, and seconds. I can't find it right now, but it's in here, so I think it's in here. Nope. I'll find it eventually. Second angle. There it is. Degrees, minutes, and seconds. So if you wanted to change that to degrees, minutes, and seconds, you'd hit 4. Enter. There you go. That's the real world. That's the real world definition, because in the real world there is no such thing as decimal degrees. Never. An architect or a construction manager or a surveyor or a civil engineer would never turn 53.13 degrees. Huh? I don't speak myself, I'm sorry. You put the answer, and then you go to second angle, which is apps, second apps. Got it? Right here. Second apps, right there. And then go down to number 4, and then hit enter. That should do it. Okay? Now you need to also be able to do that by hand. And the way that you do it by hand is you divide 60 by 13, and that will give you 7 or something like that. And I'll show you that in just a minute. That's in the book. It's not a big deal. It's just a little bit of math, that's all. But I want to make sure you can find your angle. So, look at our angle. 53 degrees. What do you mean 53 degrees? Well, that angle right here is 53 degrees. So what's this angle right here? This angle right here is going to be 180 minus this. So take your handy dandy calculator. 180 minus inverse answer equals second apps, degrees, minutes, seconds. Enter. Enter. 126, 52, 12. Now, why does Hubert not care about the 0.632? Because in the real world, you do not go that small on a theodolite or a transit. You do not go that small. In fact, the smallest transit you can get, or the most precise transit you can get, is about a 5-second transit, meaning that you can only get it within 5 seconds, which is that last 11 seconds. So if you plug 11 in, you're within 5 seconds of being true 11 seconds. In other words, that's the close you're going to get it. At 0.632, that's just academic. So in the real world, if you was to turn this angle, whether it be a horizontal angle or a vertical angle, it would be 126 degrees, 52 minutes, 11 seconds. And you would never turn 126.87 seconds. That don't even register to a lot of engineers and surveyors. Okay? So that's how you do that type of question. So just come on in whenever, that's fine. Everybody's been here, but we were waiting on you, so we finally got tired of waiting. Oh. All right, so let's do a nerd. What the heck does he want? Do the next one. Well, just hold on a minute. There, is that it? Yeah, it is. Definitely right there. So -5, +12, that's going to be right here. Find that angle. I'm sorry, I don't repeat myself. Usually I thought people listened. -5, +12, for those that didn't listen. Okay, this guy. Let's see. He passed. You know, when you get a call from somebody, and it's like, who is that? Why is that person called? Usually, they either want something or something's wrong. Here is a email. You know how they're letting emails out of Hillary's emails? Okay, this is mathematical. You ready? From Hillary to public policy polling. Your latest poll is unacceptable. We aren't paying you $760,000 per month. Y'all got that? $760,000 per month. Y'all multiply that by 12. To show a 5-point lead. Are you trying to make Trump win? That's not grammatically correct. We will be ending our contract with your company unless results improve quickly. What do you think about that? Yeah, she's lying. She's a lying thug. Well, he probably loves her. Huh? Oh, Stacy Franks. Sammy Franks. I know Stacy Franks teaches psychology. Huh? Oh, they wouldn't? No, Stacy and I are. Why? Sammy, a left-wing liberal?
I told him about you. He said, well, if you have a history lesson, you wouldn't think you really knows.
What kind of history lesson?
I don't know. Like, he would like Trump if you had a history lesson.
Excuse me. Which party endorses slavery? Which party endorsed slavery? The Democrats. Which party endorsed the creation of the KKK? I can go on and on. Which Democratic president said, if we can control these people, they'll be voting Democrat for the next 50 years? Lyndon Baines Johnson, thank you. And he was a Democrat. So what history lesson we need to talk about?
I don't know. So he likes to rail on like the colonies and unions and this is terrible.
Yeah, that was terrible, but I can't do a damn thing about that. Just like I can't do a damn thing about the Muslims. The Muslims, okay? They went into Africa, got all the slaves, started selling them, and the African people started selling them, and they brought them over here. I can't do anything about that. It was terrible. I can't do anything about it. No, he needs to study his own history.
It's also the guy that says we're going to have a really difficult time for the Boston people.
I'm sorry.
What's wrong? I need to know. Well, I mean, it's something that we're studying. It seems so easy. Double spaced,
It's all Bush's fault. Just write a paper and be all Bush's fault. You'll make an A in that class.
I was good at most of this.
Yeah. All right, so here we go. We got a line coming down. I'm trying to think. Here we go. Got a line coming down here. I'm trying to make this look pretty for y'all. And a line there. And we know that this line is negative what? Negative 5 here. And what here? So negative 5 quantity squared plus 12 quantity squared is equal to c squared. 25 plus 144 is equal to c squared. I'm trying to get a radical. Darn, 169 is 13. If I was wanting a perfect square, I would have pulled 3 radicals up. 13. So that's 13. So sine is equal to 12 over 13. So cosecant is equal to 13 over 12. Cosine is equal to negative 5 over 13. Therefore, the secant is equal to negative 13 over 5. The tangent is equal to negative 5 over 12. Therefore, the cotangent is equal to negative 12 over 5. And of course, if you want the angle, sine theta is equal to 12 over 13. Theta is equal to the inverse sine of 12, I'm sorry, 12 over 13. And what do y'all get? 67 even? No, I want to minutes and seconds.
67, 22 minutes and 40 minutes.
Thank you. 48 seconds. Now that is the coterminal. That's this side right here. That's theta. So if you want theta, you have to subtract from 180. I was trying to get a radical so y'all could rationalize, but I failed. So let's try to find one more. Let me skip a couple and maybe. All right, try that one. No, that's a quartile. Don't want quartic. There we go. Let's try that. 2, 1.7. So 2 and 1.7 would be in the first quadrant, right? So that's this one. 2 square root of 3. See what you get on this one. 2 square root of 3. I asked if it was emergency. He said not now. Oh, what'd you ask?
Is he family?
No. More likely he wants some information. So that would be 2. And instead of 3. So 2 squared, what was that? What? No. Still don't know what it was. Sound like, let's see, is equal to C squared. 4 plus 3 is equal to C squared. C is equal to what? Square root of 7. Now, if you read the directions on the previous screen, it said put everything in terms of the radical. So that means I want all 6, and then I want to know that angle. So do all your 6 trigonometric functions and give me the angle, or you can just what? Quit. And just breathe. I might have to cut class early today. I know that would break your heart. I have a friend that has a luncheon, and I might go to it, I might not. I haven't decided whether I'm going to go or not. It's complicated. I'm going to cut class early no matter what, but I'll probably sit in the parking lot and figure out if I'm going in or not.
Why is that still in?
It's complicated.
If you go to the parking lot now, then
No, you're going to stay here and work. Because I know there's one person in the class that'll go, well, I really wanted to do trig, so I'm going to complain to this department. So I have to have at least an hour of class. So. It's complicated. I got my truck. Y'all see a picture of my truck? Yeah, it does. He did something good. Huh? What do you mean? That's what body work is for. Some of it was hail damage, some of it was like interstate damage, rocks, wood. Huh?
When you hail.
I've had it for 3 or 4. It wasn't my truck when it hailed, okay? Good gosh. There was 2 or 3 dents already on it when I bought it. You know, you can't work with them instead of criticizing them. You can't work with them. Anyway, I'll show you my shirt. Some of y'all hadn't seen it, but I'm going to show it to you because I'm proud of it.
yeah, this is free body work. Where's the first?
Trying to find it. Hold on. Let me just go to my. Well, everybody don't have my Facebook, okay? Well, hold on a minute. I love that show. Dang old Forged in Fire. Y'all ever watch that? Dang old making knives out of dang old lawnmower blades and stuff. Dang old good show. Where is it? There it is. Cal did that. Bull rubbed his head up against the fender, just scratching his head, and he dented in the whole little area right there. And that was there. You ever had one of them dents that you can take a suction cup and pull out? Well, I pulled it out, but it left a little little crease, so he fixed that. And I put that one in there right there. This is hail damage and interstate. You know where paint chips? That's what those are. No, I'm gonna ride around like this. That's why I bought the different color bed. Yeah, I'm gonna ride around like this for a while. Yeah. There's the other side. Now on Dodges, the hood, I mean the thing up here is all metal. The Dodges have a bad thing about the fenders and the top of the cab. So they had to redo this one because the paint just started peeling off. So that's what that is. That's not. If you can actually see it shining a little bit. That's actual metal. And that one, I think I put that one in there. I can't remember. But anyway, they got it taped up. They're gonna dang old paint it today, I believe. They're gonna bake it overnight or something like that. Huh? This red, back the color it was. I wanted to color it black, but then they'd have to do the door jambs, and I didn't want them like messing up the inside, so I just stuck with red. So, anyway, dang old truck gonna look dang old good when I get finished. All right, so you've seen the truck. Barbara Streisand, one of those fantasy people that think if she says that Trump gets elected, she's going to leave the country. That's supposed to sway us from voting for Trump. You see what I put? Show you what I put. Let's see. Where's my comment? Keep throwing that train, dumbass. That's not my comment. I had a comment. Where'd the comments go? They took my comment off. Somebody took my comment off.
No.
Here it is. Here it is. What is wrong with us? How dare we not listen to and heed what these celebrities and athletes dictate? These are the people that keep the unicorns from fighting. These are the people that keep Candy Rock Mountain from eroding away. These are also the people that keep the marshmallow clouds puffy and the purple skies purple. We should adhere to their wishes because they are gods and goddesses to us ignorant peasants. Anybody catch the sarcasm in that? Unicorns are not real people, okay? Candy Mountain is not real. But these people, she looks like that. Hold on. No, she looks like that. You ever seen The Time Machine? That guy that what's finished for the. Yeah, but I was thinking more of Time Machine. What's his name? The Underworld King. Let me see if I can just pull that up real quick. Hold on. Okay, well, I was wrong. Well, I'll pull up Time Machine characters. Time Machine. The character is a word that I cannot spell. I always want to put as H. Is it CH? Yeah, Time Machine. There he is. That's what she looks like. You ought to put a side-by-side picture. All right, everybody look. Oops. Where'd it go? Oh, I hate these. No, I want to close the current tab. All right, everybody take a good picture, good look. Everybody got that? Got that in their head? Now I've got to find my Facebook, you know. Yeah, I see it. What about y'all? Boy, she looks rough. She's like 107. All right, we're through looking at my truck. We'll have to go back to doing this so that person won't complain. All right, so sine is equal to opposite. Oscar had the square root of 3 over square root of 7 So that means that the cosecant is equal to the square root of 7 over the square root of 3. Cosine is equal to a hump, which means adjacent over square root of 7. So the secant is equal to the square root of 7 over 2. Tangent, 2 over square root of 7. I'm sorry, 2 over square root of 3. And therefore, cotangent okay, you're right. I'm sorry, square root of 3 over 2. Okay. Square root of 3 over 2 and 2 square root of 2. All right, now we got to clean everything up because they ain't going to take some of these answers. So now multiply by the square root of 7 over the square root of 7. Here I got to multiply by the square root of 7 over the square root of 7. Here I got to multiply by the square root of 3 over the square root of 3. Here I got to multiply by the square root of 3 over the square root of 3. And the reason I'm doing extra, instead of not just flipping them, I just want to show you how to rationalize, because you can never get enough of that because you're going to forget my calculus. So that's why square root of 21 over 7, that's your answer there. 2 square root of 7 over 7, that's your answer there. Square root of 3 over 2. 2 square root of 3 over 3. Square root of 7 over 2. And the last one is square root of 21 over 3. Now we take the inverse sine. And you can do the inverse cosine if you want to. The square root of 21 over 7. And somebody tell me what you get. Degrees, minutes, and seconds. Now, I tell you right now, a lot of your tests is going to be made up of these, some way, some form. In other words, I may just give you a point. I may not show you the graph. I may just give you a point, and you got to find all this information. Now, I don't care how fine the angle. You could do the inverse cosine of 2 square root of 7 over 7. You could do the inverse tangent of the square root of 13 over 2. Either one. It's up to you. You get the same answer. All right, let's see what else kind of homework questions you got in that section, since y'all can't get into homework. So let's see what we got. That's number 8. Huh? This is another thing. This is course compass. This is what we used to have before MyLabs Plus. I said what page? Well, it was number 8. So that's, I don't see a number 8. So let's see what this one says. Same type problem. So all of those are. Let's do one more radical. And the reason I want to do one more radical is because, like I say, you're going to forget it by the time you take calculus. So have another one in there. It's not going to hurt anything. One more sneezing, please. Is that what that was a while ago? It just didn't have that chew on it. Oh. Remember, I just pick on the people I don't like. What does that say? Yeah, I'm afraid. Let's see what we want. Somebody tore down their house so they could, or move their house. It was a mobile home. They moved their house, and now they're trying to dig footers, and they can't dig footers because the county said you didn't do this and this and this, and now they're trying to do it. Anyway, that's what the problem is. I knew there was a problem, because he wouldn't have called me if there wasn't a problem. All right, so here we go. Which one is it? Well, they're both positive, so which quadrant is it in? So it could be A or B, so you need to take the square root. Square root 2 is 1.41, so it's going to be this one. Unless, no, it could be this one. That's, yeah. And then this one, square root of 14, square root of 16 is what? 4, so that's what, 3.8? So we're looking for around 3.8. 1, 2, 3, that could be 3.8. 1, 2, 3. Well, what the heck's the difference between these two? Oh, the little theta, yeah, whatever. Either one of these could be right, but they're looking for the terminal side versus the coterminal. So that's the answer. All right, so here we go. Drop that line down. Dang old, get your handy dandy straight line maker and drop it down there and there. And that's going to give you the square root of 2. And what was square root of 14? So square root of 2 is 2, 14, 2 plus 14 is 16. So that's going to be 4. So now and you should be finding yourself skipping a few steps. That's a good thing. That means you're not a failure. Sine, cosine, tangent, cotangent, secant, cosecant, and the sine is going to be equal to Oscar had, which would be square root of 14 over 4. 4 over square root of 14. And then cosine would be adjacent square root of 2 over 4. 4 over square root of 2. Oops, I messed up. 4 square root of 14. And 4 square root of 2. And then the tangent. Oscar had a hunk of apple, so that's going to be of apple. So, I'm sorry, of apple. So square root of 14 over square root of 2. Square root of 2 over square root of 14. And that one's okay. That one's okay. This one, square root of 2 over square root of 2. Square root of 28 over 2. We can reduce that down a little bit more. Right now, I'm just going to circle these as the answer. That can be 2 square root of 7, something like that. And then the 2 cancel out, so you left with square root of 7. Square root of 14. Oops. Square root of 14 is equal to square root of 28 over 14, which is going to be equal to 2 square root of 7 over 14, which will be square root of 7 over 7. Somebody check me on that. Kind of clamp here. And then this one, square root of 14 over square root of 14, and that's going to be 4 square root of 14 over 14, which is equal to 2 square root of 14 over 7. And the inverse sine of square root of 14 over 4. Somebody give me the degrees, minutes, and seconds. I'm sorry.
69 degrees.
Don't get attitude.
17 minutes, 33 seconds.
Now that's 3 or 4 problems we did. You should be able to do it now. And like I say, you're going to see a lot of those on the homework, and you're going to see a lot of them on the test. All right, let's go do something else. It's 12 o'clock now, so I'm going to show you one more thing before we quit. Some of you, I'm sorry, what?
The secant to 4 over 2 squares,
Mm-hmm.
or the square root of 2,
You shouldn't have a square. You have a square root of it.
you don't have 4 over 2
I thought one of them had a 2 in the denominator. I don't erased it. I'm sorry. If it has a square root in the denominator, you need to rationalize. I must have skipped one. I thought one of them had a 2 in it. If I left one off, I'm sorry. Yeah, you would do that one if it had a square root on it. Yes. Okay. What I wanted to show you. I added a couple of things to my, not this one. I'm sorry. Okay, hurry up. Da 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 da. There. Now I showed you these, right? This one's 30, this one's 45 degrees, and this one's 60. I showed you those, right? All right. Now, your unit circle. Everybody should be able, I don't know how many of you, I showed you the unit circle the other day. I told you that you need to learn how to draw it, not memorize it. This is the way you learn how to draw it. I don't know if I went through this. I think I started to, but I didn't have this slide, so I went ahead and I went home and I did the slide, so just watch it and then see if you can grab on to what I'm talking about. And you remember the, okay, I don't know why it's not, oh, I'm not hitting right. My computer at home, I hit enter. This thing, you have to do this. See, I'm putting numbers around it. I'm not used to the way this computer works. There's your 30-degree angle, and then it goes across. There's your 45-degree angles next. You took 30 there, and then you put 30 pi over 180, and then you reduce it, and that's that. And then you take 180 and add 30, and that's 210. And you take 210 pi over 180, and you simplify it, 7 pi over 6. And 45, it comes in last, and there's your 60. For some reason, I put the 45 in differently. I don't know why. All right, that's what you need to remember. You don't need to memorize it. You don't need to, regurgitate it. You just need to think 30, 45, 60. And then come over here and say, what's 180 plus 30? 210. What's 180 plus 45? 225. What's 180 plus 60? 240. And then take those three numbers, 210, 225, and 240, and multiply by pi over 180. Simplify it, and then you've got your 7 pi over 6, 5 pi over 4, 4 pi over 3. There's no memorizing. Okay? If you try to memorize it, what's going to happen is you're going to forget it, and then it's going to be gone, and you're going to have to re-memorize it because you memorized it before. It's better just to learn it. Now, how would you do the second and fourth quadrant? Well, the second and fourth quadrant, what's 180 minus 90? What's 180 minus 30? So that would be 150. What's 180 minus 45? And then what's 180 minus 60? And then and we did this the other day, but we didn't, I drew it kind of half-assed. So this, you should be able to fill out the other one by saying, what is 360 minus 30? What is 360 minus 45? 315. And what is 360 minus 60? And then you change them to pi over 180, or multiply them and then produce it. So make sure you can do that. I want you to take a piece of notebook paper. I want you to be able to take a coffee can or whatever, draw a circle, and I want you to be able to fill that thing out. I don't care how long it takes you. It shouldn't take you no more than 5 minutes. All right? But I do not want you to memorize it. I want you to be able to draw it based on the 30, 45, and 60-degree angle and the pi over 180. And I think it's going to help you much more than memorizing. Okay? And that's reciprocal ends. We're not going to go over that today because I'm going to go ahead and call class off today. Not call class, we're going to go ahead and call class. So what I'm going to do now is I'm going to stop this thing, and I'll call the roll, then we'll go from there.